All right. Hey, everyone. Welcome to day 15 of Math 133. So today is July 7th. Hopefully everybody had a good 4th of July holiday. Um, yes, today we're going to cover the cumulative review number 5. So we're going to skip number 4. I don't know if that matters to you, but uh, it is on page 550 in your course pack, and it covers chapters 1 through 8. We haven't finished chapter 9 yet. We will do a cumulative review a little later that's going to cover up through chapter 9. Chapter 9, we're going pretty slow through it because it's a lot of material. It's difficult. So you'll notice that we are assigning the 9.2 lecture notes. So make sure to have those done by Wednesday. Okay. Um, so if you are here in class today, great. If not, if you're listening to this recording and you also miss Wednesday, July 9th, you're going to need to go to the weekly participation boards. And today we are starting week 8. So you'll need to fill out the discussion board there. So for all of you who are in the class, though, you don't need to do that. So uh, as far as grading and stuff, so I'm still working slowly through the grading. So if there's points in there that you're like, hey, how come this hasn't been scored yet? Don't worry. Uh, I've been we had a 1-year-old birthday party, so I've been busy with that. So I haven't had a chance to do much grading. So okay, so another thing to note is on Wednesday we have our candy project. Okay. Um, so the candy project, you're gonna need to buy some M&Ms and some Skittles. And I messaged in remind about that. Okay. So you're gonna need probably more than 2 ounces of M&Ms. Okay. So the normal size package is like 1.5, and it has like 55, 56 candies in it. Um, so that's not enough, right? We've talked about making sure our sample sizes are big enough. Okay. So if your sample of candies is, only 56, uh, we're doing it as a proportion. So you need to multiply that by, what's the probability of each of the colors actually showing up in there. So you'll remember that N times P times Q has to be greater than 10. And if you have uh 55 candies in there and there's 6 different colors, then 55 divided by 6 is 9. So you're going to get 8 or 9 of each color, and that's not bigger than 10. Okay. 2 ounces, you should be good. 3, 2.5. If you want to get like, a 5 ounce or, you know, 10 ounce bag, that's fine too. Um, Same thing with the Skittles. So yeah, you got mini Skittles, that's totally fine. Sounds good. Um, so I made a joke in the remind that we need to make sure that our sample size is big enough, so more than 2 ounces, but also not too big, right? But nobody's going to buy more than 5% of the M&Ms in the world, right? That's never going to happen. That's so expensive. Like you wouldn't be able to do that. So don't actually worry about too big. But I guess if you buy one that's the super giant one, you're gonna have to count a lot. So, but you get to eat them. Okay. So on the 9th, we're gonna do the candy project, and then after that, you can eat them. So uh, the data that we're gonna collect for the project, we're gonna use it for chapter 9, chapter 10, and chapter 11 projects. Okay. Um, and so you'll notice chapter 9, we're going to cover that on Monday, the 14th. Chapter 10 project is on Monday, the 21st, and chapter 11 project is on Monday, the 28th. So we're going to need the data for the Skittles that you had. Um, so make sure after we've done the candy project this Wednesday, you can eat them, that's fine, but make sure you save like your counts in a place that you'll remember where to find them, okay? Is there a reason why the Skittles have to be original? Yes, there is. It's because we need to make sure that we have colors matching between the M&Ms and the Skittles. So, you've got yellow and red and so on. So, um, Yeah, sorry about that. Some people like the more exotic Skittles. I get you. Um, okay. Yeah, and so make sure you have those for Wednesday. Okay. Um, we started telling you about buying them last week. Um, we try not to tell people too early to go out and buy the candy because if we do that, kids find it, spouses, husbands eat it, and you're like, you ate my homework, so we don't want that to happen. Okay. Okay, so there's that. So that's on Wednesday. Um, Elaine, it looks like 9.3 lecture notes are not assigned in here. Is that correct? Do we skip 9.3 or do I need to fix that?
Yeah, no, we don't do section 9.3.
All right, great. All right, sounds good. So 9.2 for today is what we're assigning, and if you are working ahead, you can skip 9.3 and do 9.4. Almost ate my own one. Okay, so uh let's go to the cumulative review, which is on page 550. Okay. Okay, so uh page 550, covering everything up through chapter 8. So Joe Hopkins. Okay. Um, okay. Following data shows the number of hospital beds in a random sample. Okay, so here we are asked to find all these different things. So mean, median, mode, all of these different things. We've done this before, right? So we have our raw data here. And when we're trying to find mean and standard deviation, we had three different methods depending on what we have. In this case, this is the raw data. So on page 232, there were three methods we talked about, and so this one is method one. Okay. And that's what you're gonna do if you have the raw data. Okay. This spot right, by the way, is supposed to be Q1. We left it blank. Sorry about that. So quartile one. Okay. Um, all right. Fences, we talked about on page 84 in our course pack. Okay, so there's a formula for that. Okay. Um, and then what appears to be the shape of the distribution. It's on page 87. Okay. Which measures of central tendency should we use here? Also on page 87. Okay. So find the z-score of a hospital with 150 beds. Okay. So that is on page 231. Okay. Uh, so there's a formula for that, right? It's you take the X value they give you, and then you subtract the mean, okay? And then you divide by the standard deviation, okay? And that gives you a z-score, okay? Now, the z-score could be any number. It is not a probability, okay? So when we ask, is it unusual, okay? That's on page 80, okay? And a lot of people were struggling with how to talk about whether something was unusual, okay? Something is unusual. We need to keep track of whether the numbers that we have are a z-score or a probability, okay? If it's a z-score, then you can say it's unusual if z is bigger than 2 or if z is less than -2, okay? Why do we use 2 and -2? That's because those correspond to a probability that is less than 5%, less than 0.005. So if you have a probability, you'll compare it to 5%. Okay. This one is not getting us a probability, so don't compare it to 5%. You compare it to these z values. Okay. The reason why we use 95%, or sorry, 5%. Um, so 5% gives us uh, z values of -2 and +2, and this in here would be 95%. Okay, so that means that anything past 2 or -2 is going to be 5%, the remaining 5% out of 100%. Okay. So that's why we're using 2 and -2. Okay. All right. So just keep in mind whether you have z's or probabilities. Okay. All right. Next page is page 561. 551. 551. Sorry. Okay, so on this page, uh, following box plot shows violent crime rate. Use this below. So, um, this is looking at box plots, and we talk about those on page 85 through 87, okay, in our course pack. So a lot of this stuff we've seen before, right? This is a review of everything up through chapter 8, and we do a lot of reviews, okay? And that's partly because we need repetition to understand this, okay? If we go over box plots one time, or mean median mode one time, like then when we start talking about z-scores and you got to subtract the mean, it's like, okay, how do I get the mean and the standard deviation? Like, so repetition is the key here, okay? But also, we're studying for the final exam as we go, okay? We don't want you to have to go back and relearn everything. So down here, find the following. So this one is on page 235 in our course pack, parts 1 and 2, okay? So if it was 95%, then my answer is easy. It's -2 and +2. Or if it was 68%, that's 1 or -1. 99.7% is 3 standard deviations. And we have that memorized, okay? We don't have 97.5%, okay? So I'm not sure what the numbers here will be, but here we're shading everything in here between these two z values. We have to find those z values, okay? They give us this 97.5% shading, okay? Okay. Next, let's look at page 552. A random sample of movie budget amounts is taken. It's reasonable to assume this is coming from an approximately normal distribution. So we talked about that on page 163. Okay. All right. Number 5, write the appropriate symbol for the given term. So we've done these before. So you guys should probably have that covered. No problem. All right. Repair times for air conditioning are normally distributed with a mean and a standard deviation. So this one, you'll find information about it on page 235, parts 3 and 4. Okay. Find the 3 missing values. So here, where do we want to start? Well, so we'll want to start these down here. These are x values, and we're going to use x and z interchangeably in this class. Okay. So this is an x-axis, but you could convert it to a z-axis using z-scores, right? We've talked about that before. These up here, though, these are probabilities. So, there's a way in StatCrunch to connect z-scores or to probabilities, right? But you need one of them. So you can't start here because I don't know either of these two numbers. So I could start over here with this one because I have my x value and I can find my probability first. Okay. Um, Provide an explanation of A1 and X2. So A1 is this guy, X2 is over here. That's not correct. This is a typo. This should be A1 and X1. These two are related because A1 is not related to X2 at all. Okay. These two are related. These two are related. Okay. Okay, so you can find how to do that on page 161. Don't forget to interpret what this means in the context of the situation, which means you need a direction word. Okay. More than, less than, between, Okay. All right. On our last page, okay, we will give you a few more hints and then we'll jump in and do some math. Okay. So, all right. Figures below show three sampling distributions of sample means randomly from a population with a standard deviation right there, with sample sizes 3, 6, and 12. Okay, so those are terrible sample sizes. None of those are bigger than 30. So that's no good. So, but if you were trying to make sure that you were following the central limit theorem, you would need those to be bigger than 30. And the bigger our sample size is, the smaller our spread will be. Okay. So the one that has a very wide spread is going to be a low sample size. And you'll notice this doesn't look normal at all. It looks like a mess. Okay. Versus a much smaller spread, you get closer and closer to a normal distribution and you get more accurate as you increase your size, okay? Um, so this one is on page 165 and 169, okay? Um, so the formula, what is the standard error for the distribution with the smallest spread? So the smallest spread would be this guy up here, okay? So whatever sample size you use for this, that's what you're going to use in the formula. So formula is on page 166 for standard error. Okay. Okay. Survey found that 59%. So when we see 59%, that's our p-value, right? So I think that TikTok is a threat to national security. Random sample. Verify that the central limit theorem for proportions are met. So there were three conditions. It had to be random, okay? It had to be independent, okay? So those two are going to be the same whether you're using the central limit theorem for proportions or means. Basically, is it random? Is the word random is somewhere in there? Independent, meaning it's not too big, so it's less than 5% of the entire population. The one that's different is normal. So it depends on whether we are talking about means or proportions. Here we're talking about a proportion, okay? And I know that because of the percent here. So because of that, I need to make sure my sample size is big enough. So I can't just say it's got to be bigger than 30. That's what I did for means. For proportions, you actually have to do a little more work. You have to multiply Pn times P times Q because it's not just that you have to have a sample size of 30, you have to have enough successes and enough failures. You have to have more than 10 of each. So you're going to need to put in what your N is, multiply by your P, multiply by your Q. That's going to give you some number, and that needs to be greater than 10 or greater than or equal to. Okay. And all that information is on page 170. Okay. There's an example on page 171. Okay. Um, if the central limit theorem is met, then we can talk about the sampling proportion, sampling the distribution for the proportion. And so we can talk about the shape and the center and the spread. Okay. Um, all right, cool. So those are all the hints I'm going to give you. I'm gonna stop the recording and we're gonna do some math. We're gonna get all these answers filled in tonight.